Okay, then that brings us to example 6. And example 6 is going to be the big one. I would like to look at the limit as x approaches infinity of 1 plus 1 over x all raised to the x power. Okay, so let's look at what the form of this limit is. The form would be that inside of the parentheses, that's 1 plus 1 over infinity, so that's getting very close to 1, while the exponent is getting very close to infinity. So this has a form of 1 raised to the infinity power. Your gut would tell you that 1 raised to any power is 1, but keep in mind this is something that's close to 1 being raised to an incredibly, incredibly, incredibly large power. And so we cannot guarantee that this will end up being 1. This is also an indeterminate form. Okay, so how do we go about this? Well, just like in the previous example, I need to turn this into infinity over infinity, or 0 divided by 0. And the way that I'm going to do this is as follows. I'm going to call this limit equal to y. And then I'm going to take the natural log of both sides. What? Where did that come from? Okay, so this is going to be the natural log of the limit as x approaches infinity of 1 plus 1 over x all raised to the x power. Let me do a little bit of algebra here. I have not used L'Hopital's rule. The limit can be moved outside, or I can think of the natural log being moved inside. So this, give it a little more space here. This will be equal to the limit as x approaches infinity of the natural log of 1 plus 1 over x all raised to the x power. And what this does for me is that I've got a log of something raised to a power, and the properties of logarithms say that the power can be moved out in front. So this is now the limit as x approaches infinity of x times the natural log of 1 plus 1 divided by x. Okay, so let's look at the form of this limit. As x is approaching infinity, x is approaching infinity. And then as x is approaching infinity, we look at the natural log of 1 plus 1 over x. Inside of the parentheses here, this is approaching 1. So this is getting close to the natural log of 1, which means that it is getting close to 0. So right now, my limit has a form of 0 times infinity. Well, that's what we saw in the previous example. So I need to turn this into something that L'Hopital's rule can use. I can either take the first thing and move it into the denominator, or take the second one and move it into the denominator. I think we can all see that moving the first one into the denominator algebraically is going to be a lot nicer. So as x approaches infinity, I'm going to get the natural log of 1 plus 1 over x all divided by 1 over x. Now, if I look at the form, the numerator is approaching the natural log of 1, which is 0, and the denominator is 1 over infinity, which is 0. So I have now gotten this to a point where I can use L'Hopital's rule. So that's what we'll do in the next step. Take the derivative of the top and the derivative of the bottom. And actually, I am going to do one more step of algebra here, just because I know that the derivative is going to be easier if I take advantage of the fact that 1 plus 1 over x, well, 1 is x divided by x, so this would be x plus 1 divided by x. So this is the natural log of x plus 1 divided by x, all divided by 1 over x. And that's just going to make the derivative a little bit easier. So I am now ready to take L'Hopital's rule. So I will make a note. I am using L'Hopital's rule. And the limit is exactly the same. X is approaching infinity. And then I've got to take the derivative of the top. Okay, the derivative of the top. Let me scribble some stuff over here. I need to take the derivative of the natural log of x plus 1 divided by x. This is going to be the natural log with a chain rule. So that would be 1 over x plus 1 over x multiplied by the derivative of x plus 1 over x. Right? That's what the chain rule would say. Okay, well this, I could flip over the denominator and get it to be x divided by x plus 1. Then I need to multiply that by the derivative of x plus 1 over x. So this is the quotient rule, which I'm just going to do really slowly. I've got the bottom, x, times the derivative of the top, 1, minus the top, that's x plus 1, times the derivative of the bottom, which is 1, all divided by the bottom squared. That's x squared. Then I need to divide that by the derivative of 1 over x. Remember that 1 divided by x is equal to x to the negative 1. So that derivative is negative x to the negative 2. Wow, that's a mess. Okay, let's clean up the mess a little bit. So now we got to do a bunch of algebra. This will be the limit as x approaches infinity of, let's get a clear look at this. I think that in the top there, I've got x multiplied by x minus 1. So that looks like minus 1. So this right here is x minus 1. And in the denominator, I have x plus 1 times x squared. And then in the big denominator, I've got negative 1 over x squared. I think we did all that right. So what can we clean up? There's a negative here and a negative here, so those are going to become positive. This x squared is going to cancel with that x squared. And so it looks like all I have is x over x plus 1. That's not bad. So this has become, I'll do it in blue, the limit as x approaches infinity of x divided by x plus 1. That's something that we recognize from the beginning. That's totally fine with me if you recognize that I've got a first degree polynomial divided by a first degree polynomial. And so it's going to go to the ratio of the coefficients of the highest exponents, and that limit is going to end up being equal to 1. Now here's the thing, we're not done, because I want you to remember where this all came from. If we scroll all the way back up, remember that we were trying to evaluate this limit, but what we actually evaluated was this limit. So we're trying to find y, and what I just found was the natural log of y. So if I scroll all the way back down, we just found that the natural log of y was equal to 1, which of course implies that y is equal to e to the first power. So my original question, what is the limit as x approaches infinity of 1 plus 1 divided by x raised to the x power? The answer is e to the 1. Wow. You guys should probably do some homework.